efficacy of first derivative test and second derivative test, which is when to be used. So consider f of x is equal to x cubed minus 6x squared plus 9x plus 5. Okay, first part of the question, which we'll do first, is find the points of minimum and maximum. So these are local minimum and local maximum. Find the points of minimum and maximum of this function and corresponding function values. All right. So this is something simple which we all have done, and this everyone really knows how to do it. But here, please pay attention. I'm going to do it in 2 ways. I'll use first second derivative test, which is easy in this case, and I'll do the first derivative test. Next. So using second derivative test, this is f of x. F of x is x cubed minus 6x squared plus 9x plus 5. Now differentiating, this implies f dash x will be 3x squared minus 6 into 12x plus 9, which will be 3 into x squared minus 4x plus, which turns out to be 3. You can see you can factorize this. 1 into 3 is 3, and sum of that is 4. So we can write this as the factors will be 1 and 3. So x minus 1 into x minus 3. So for f to be attaining a minimum or a maximum, f dash x, the first derivative must be 0. So f dash x equal to 0 by either x equal to 0 either x equal to 0 or x equal to 3. Okay. Either x equal to x equal to 1 or x equal to 3. So for f to be attaining minimum or maximum, this is so at these 2 points, x equal to 1, x equal to 3, derivative is 0. Now will it be maximum or minimum? Let us check. For that, we apply the second derivative test. Second derivative, second derivative of it is, now we will not differentiate this part, this factorized part. It is better to differentiate this polynomial form. Okay, so you get 6x minus 12. Now second derivative is 6x minus 12. Now at x equal to 1, the second derivative will be 6 into 1 minus 12, that is minus 6. Second derivative is negative. Therefore, at x equal to 1, f attains the maximum value. Because when second derivative is negative, remember, curvature will be convex. That means this point will be the point of maximum. Now, at x equal to 3, the second derivative at 3 will be 6 into 3 minus 12, that is 18 minus 12 is plus 6. It is positive. Therefore, at x equal to 3, f attains the minimum value. So, x equal to 1 is the point of maximum, and x equal to 3 is the point of minimum. Here, f second derivative is negative, the second derivative is positive at this point because of the curvature. Okay. So now let us find the minimum and maximum values. So f of 1. So f of x is, first let us write f of x. F of x, which is x cubed minus 6x squared plus 9x plus 5. So the local maximum value and x equal to 1 and x equal to 1 is f of 1, substitute in this, 1 cubed is 1, 6 and 1 square is 6, plus 9 into 1 plus 5. So 1 plus 5, 6 minus 6, 0, you get plus 9. This is the local maximum value. Okay. Local minimum value at 3, f of 3 is 3 cubed minus 6 into 3 square plus 9 into 3 plus 5, which is 27 minus 9, 6, 54 plus 27 plus 5. 27 plus 27, 54 minus 54 plus 5 is 5. So at 1, the value is 9, at 3, the value is 5. So this is the local minimum. The second derivative test. Now, I would wish to highlight an alternative method using the first derivative test. This is faster in many times. So f of x cubed minus 6x squared plus 9x plus 5. First derivative as we found out earlier, again I'm writing 3x squared minus 12x plus 9, which is 3 into x squared minus 4x plus 3, which is equal to 3 into x minus 1 x. So this is f dash x. Now f dash x is equal to 0. At x equal to 1 and also at x equal to 3. At both these points, the function is the derivative is 0. Now, just using the first derivative test, let's draw the number line like this, and let these be the points 1 and the point 3 on the number line. Okay, this is the point 1, this is the point 3 on the number line. Now, I want to find the sign of f dash x. So, I'll use the number line sign scheme. What it says, as long as the coefficients of all the factors are positive, coefficients of x in all the factors, all the linear factors, these are all linear factors, is positive, and for all the factors, the derivative, the powers are odd. If there are even powers, that factor should be omitted. But if they are for sign consideration, if they are odd powers, the sign should be considered. And if all the coefficients are positive, go to the extreme right, write a plus sign. Alternatively, put a minus sign and put a plus sign. Because the coefficient of x square is positive. Coefficient of all the products, the coefficient is positive. So when x is greater than 3, x minus 3 will be a positive factor and x minus 1 will be a positive factor. So product of two positives will be positive. So in all this region, the derivative will be positive. In between 1 and 3, x minus 1, when x lies between 1 and 3, x minus 1 will be a positive factor, but x minus 3 will be a negative factor. So product will be negative. So that's why it's negative, positive. Next here, both will be negative. So therefore you get positive. So there's a number line sign scheme. If you remember, we just draw like this, plus, minus, plus. It's very easy. Once you have practiced, it's very simple to do it. So now f dash x is pairing like this. It is not f of x, it is f dash x. So just a scheme, you don't have to draw this curve like this. Just to, so now at this particular point, f dash x at x equal to 1 is changing its sign from positive to negative. So f dash x is changing from positive to negative means at x equal to 1 in the real graph of f of x, this is at x equal to 1, your f dash is changing from positive to negative when you move across x equal to 1. That can happen only when this is the point of maximum. So we know that at f dash x is equal to 0, there has to be a maximum or minimum. So this particular point, f dash x is 0, right? And f dash x changes its sign from positive to negative. Therefore, it is a point of maximum. And this one, f dash x changes its sign across this point 3 from negative to positive. So it will be like this in the real graph of f. This is real graph of f. So across that critical point, so the derivatives are changing from negative to positive. So this is the point of minimum. Clear? So this is the first derivative test. So I didn't do anything. I didn't have to do a second derivative. I straight away found the point, which is the point of maximum and which is point of minimum. So therefore, the local minimum, local maximum at x equal to 1 is f of 1 which we found out to be 9. And local minimum at x equal to 3 is f of 3. Okay. So this is a simple algebraic equation. Now, in general, when there is an algebraic equation and it's a polynomial, it's an algebraic polynomial. Doing second derivative test is very easy and straightforward. In other cases, I'll take an example next. It will appear difficult to take second derivative. All right, we will discuss that. But there is one more component to this question, which I would now want you to look into. Find the global minimum and global maximum. Find the global minimum and global maximum of f, same function f, in the interval, let's say minus 1, minus 1, it's an interval, minus 1. So what we should do, according to the previous, the discussion that we have to find the critical points and the end points of the interval and the critical points. We have to identify and choose the minimum maximum value. So we already found the critical points. So the critical points are x equal to 1 and x equal to 3. Now, for which the function values are f of 1, f of 9, and f of 3. Now, let us find f of x equal to 1. It's x cubed minus 6x squared plus 9x plus 5. We will find f of minus 1 at the boundary. At the critical points we have found, we have to find at the boundary of the interval. F of minus 1 is minus 1 whole cube, which is minus 1, minus 6 into minus 1 whole square, that will be 1, plus 9 into minus 1 plus 5. So we get minus 16 plus 5 is minus 11. Minus 9 minus 1 is minus 10, minus 16 plus 5 is minus 11. What is f of 3? F of 3 is 3 cube, sorry, not 3, f of 5. F of 3 is already a critical point. The next, the rightmost boundary. So 5 cube minus 6 into 5 square plus 9 into 5 minus 5. So we get 125 minus 25 is 115 plus 45 plus 1. We get minus 150 plus 50 is minus 100, 125 minus 100 is 100. So now we have to choose n smaller is minimum of function value at the boundaries and the function value at the critical points. which is the minimum? Minimum of -11, 9, 5, and 20. Which is the least? -11 is the global minimum. Alright. Capital M is the maximum of the same thing. It is the maximum of -11, 9, 5, 25. 25 is the maximum. So global minimum is -11, global maximum is 25. Amongst this. If the interval changes, of course, minimum maximum values change. So I'll just try to depict this. I will try to explain certain things about graphs. Pay attention. Here, this is y equal to x cube minus 6x square minus 6x square plus 9x plus 1. See the function, how it looks. Generally, it's a cubic function. Remember, when the cubic function has positive coefficient of x cubed, the highest degree, the positive coefficient, the function tends to go, as we go to the right, the function goes to plus infinity, as we go to the left, function goes to minus. And this is the way there will be two. Generally, there will be two stationary points where the derivative is 0. Now, suppose I change I'm just trying to change and show. That if it's a quadratic, if it's a close, right to the end. So y equal to x cubed minus 6x plus 9x. Now I'm just introducing the minus sign and see how it changes. Same thing with the minus sign. I'm writing this graph. and see this graph now. And you do a minus sign, again you get two critical values, but the curve goes from left side it goes to positive infinity, right side minus infinity. If I change this way, it is like this. Okay. So if you have some idea of these graphs, it will be very, very useful. Now I'll show you quadratic graphs. Now, quadratic graph, the positive coefficient of x squared. Gray color. So let's say positive coefficient of x squared. This is the graph. Positive coefficient of x squared, it will be parabola opening upwards, and this is, the single stationary point. It will happen. If the same thing I have a negative sign, it will be a parabola opening downwards. So these things, just seeing the equation, mentally we can tell whether it will be minimum, maximum, and so on. So many times, without, I will do some exercise problems with you, where this understanding will help you, straight away get to the solution without even actually solving the problem. So now let us see this value. This is 9. Yeah. If I click this point, this point, see, it is 1, 9. At x equal to 1, the function value is 9. For this graph, x cube minus 6x squared plus 9x plus 5. And for x equal to 3, you get a minimum value, which is 5. But at x equal to minus 1, at x equal to minus 1, the value was minus 11. Here. When x is equal to minus 1, the value is minus 11. And for x equal to 5, this is 4, this is 5. For x equal to 5, for x equal to 5, what is the value we got? 25.
25, sir.
For x equal to 5, we got 25. So that's how the graph looks like. The graphical understanding of cubic functions and quadratic functions is useful. And if it's a biquadratic, suppose I add another term of x power 4, then I can show you that also. I'm just suppressing all these points. Now, I'm adding x power 4 term. See here, g of which I'm adding x power 4. Term 1, 3. I will add 0, 1, 4. So Here we see there is 2 points of maximum minimum here. One minimum, one maximum, and at the bottom here there is another. Of course, if I change this to positive, I'm just playing with sum of the roots, products of the roots, and polynomials. That's all. So here we see when x is equal to x power 4, we get a graph more like a distorted W. And x power 4 is a negative coefficient, then it will reverse. Okay, that's why if you see when I did this graph, I said this is a polynomial of degree 5. Why? Because it will have 4 stationary points. Because polynomial of degree 5 will have derivative of the 4th degree, and it can maximum have 4 roots. So these are the 4 roots: 1, 2, 3, 4. So this is a polynomial of degree 5. With I can also predict that this has a negative coefficient of x power 5, because this is going to plus on the negative side and minus on the positive. So these understandings help us to solve the problem very, very efficiently. That's why I'm emphasizing this. Otherwise, just blindly mathematical calculation or second derivative test you can do. To make it more efficient, sometimes we can do first derivative test. This is a global maximum. Next, I'll give another question, which will be of importance. There's a second example. Now, consider f of x is equal to x minus root of 4 minus x squared. Okay. Now, find the local minimum and maximum value of this function. So now this is not a straightforward polynomial. It is an irrational algebraic equation. So f of x is this, x under root of 4 minus x squared. So differentiating. When we differentiate, we have to differentiate derivative of the first function, keeping second constant. So derivative of x is 1 plus keeping the first function as constant, differentiating the second. It's 1 by 2 under root 4 minus x squared into derivative of the expression within the root by chain rule minus 2x. Okay, what happens? 2 cancel. Then we bring it to the common denominator. Under root of 4 minus x squared multiplied by itself will give 4 minus x squared, and this is x into minus x, which is minus x squared by under root of 4. We get 4 minus 2x squared by 4 minus x squared under. This is the derivative. Now, the common sense tells us that going for the second derivative will complicate the issue. We can get it, but it will take more time. But anyway, if first derivative has to be equated to 0, we get 4 minus 2x squared, which will give us x as plus or minus under root 2. Now, I will go by the first derivative test only. In this particular problem, if it was a simple plain polynomial, then second derivative test is easier. In this particular case, first derivative test is easier. So now f dash of x, I will write as take 2 common, or say minus 2 common. I get x squared minus 2 by under root of 4 minus x. And this is x plus under root 2 into x minus under root. Now, in the domain of discussion, when x is around plus or either plus root 2 or minus root 2, the denominator is under root 2. Okay, we can very clearly see that. So denominator exists, so we don't have a problem. So, and it is positive. So sign, it does not contribute in the sign change. This remains the same value. The factors that change sign across the critical points x equal to minus root 2 and x equal to plus root 2 are these two factors. So now let us plot the number line. We plot the number line. In the number line, mark minus under root 2, mark plus under root 2. Okay, just put the factors, don't put 0 or anything. Just mark only those values which are the roots of f dash x equal to 0. Now, when I go to the extreme right, it should be positive, the product, because coefficients of x squared, x and x are positive here. However, it has a negative sign. So although these two factors will both be positive, multiplied with the negative sign, f dash value will be negative. Conversely, now for the next interval, the product will be negative, but it is multiplied with the negative sign, it becomes positive. And in this interval, the product is positive because both are negative values, and multiplied by a negative sign. So negative into negative is positive, multiplied by negative will be negative. So you don't have to worry on it. In all linear factors, when you have to the extreme right, you just put positive if the overall coefficient is positive. If overall coefficient is negative, extreme right is negative, and the next interval positive, next interval negative. So of course, because this is f dash, this is f dash x. Now by first derivative test, please tell me what will this value be? Which point? This at this point it's an extremum, either minimum or maximum. Now tell me what is this?
The point of minimum.
Good. It is the point of minimum because f dash x is changing sign from negative to positive. The slope is negative to positive. So this is the point of minimum. And this is the point of maximum because f dash is changing its sign from positive to negative. So first derivative test helps us in this problem. It will save time. We can go for the second derivative test. We will have to apply by u by v rule of differentiation, and you can try it, and you should get it. If you want, I can still do it, but I leave it here. There is an exercise problem, practice problem on this type that I have given you. You can look into that. Exactly this morning, just a number change. So we found out the point of minimum and point of maximum simply by the first derivative test. So the minimum value is at x equal to -2, and the minimum value is f of -2 is x into under root of 4 minus x square. So x is -2 in under root of 4 minus under root 2 whole square. Minus 2 into 4 minus 2. So minus 2. The maximum value is at x equal to plus under root and f of under root 2 minus 4 minus square. This is the maximum. Clear? So first case was a simple polynomial. The second case was a irrational. Third problem. It's a trigonometry. Consider f of x is e power sin x upon e power cos x. Find the maximum and minimum values of it. Now, this is exponential function. F of x can be written as e power sin x minus cos x. Now, we know that an exponential function is an increasing function. So, this is the graph of the exponential function. Yeah. The exponential function is an increasing function. So, as x increases, e power x increases. So here instead of x, we have another opposite function sin x minus cos x. So we can treat this as e power g of x. And since e is an increasing function, so we just have to find the greatest value of g and the least value of g. Okay, as e power x is an increasing function, strictly increasing. All right. Now, e power g of x is maximum when g of x is maximum. And it is minimum when g of x is minimum. Okay. So now let us look at this. Here g of x is sin x minus cos x. So how should we do? Anybody can volunteer? How should we do? I have to find. So my problem now lies in finding the minimum and maximum values of sin x minus cos x.
So sin x minus cos x, I multiplied and divided by under root 2, and then I used.
Yeah, that is good. See, we can differentiate this. We can differentiate this as it is. but that will complicate the issue. Meaning not complicate, you can still do it. It's not a problem, but better is multiply and divide by under root 2. And then this becomes sine of x minus pi by 4. This is sine A cos 45 minus cos A sine 45. So sine x cos 45 minus cos x sine 45. That is sine of x minus 45 or x minus pi by 4. So if this is g, if I have to differentiate, under root 2 remains constant. Derivative of sine is cos. This makes it easy. So this is the derivative. Now if g dash x equal to 0, it means cos of x minus pi by 4 is equal to 0, which implies x minus pi by 4 is, minus pi by 2 plus pi by 2 minus 3 pi by 2 or plus 3 pi by 2, so on. So odd multiples of pi by 2. Okay. So which means that x will be add pi by 4 to it, to all of these. You will get minus pi by 4 plus pi by 2 plus pi by 4 is 3 pi by 4. Then 3 pi by 2 plus pi by 4 is 6 plus 7 pi by 4 and 11 pi by 4, so on. All right. Now, alternatively, now if now let us look at the second derivative. It will be under root 2. Derivative of cos is minus sine of x minus pi by 4. So what we get now, let us check at minus pi by 4. We get minus root 2 sine of minus pi by 4 minus pi by 4, that is minus pi by 2. Sine of minus pi by 2 is minus sine pi by 2, which is minus 1, 2, greater than 0. So therefore x equal to minus pi by 4 is the point of, it's the point of minimum. It is the point of minimum. Okay, because the second derivative is positive. Now these are problems with the net connection. All right. Now second derivative at 3 pi by 4 is minus root 2 sine 3 pi by 4 minus pi by 4, that gives us pi by 2, and sine pi by 2 is 1, so minus root 2. Therefore x equal to 3 pi by 4 is the point of maximum. Okay, and 7 pi by 4 is nothing but 2 pi minus pi by 4, so that is 7 pi by 4. And 11 pi by 4 is 2 pi plus 3 pi by 4 is 11 pi by 4. So these are like in the intervals of 2 pi, and this function is periodic. All right. This function here is periodic with period 2 pi. So therefore, this will be a periodic expression. So minimum and maximum keeps happening here. So if you find just g of minus pi by 4, it is root 2 under root 2 into sine of x minus pi by 4, that is minus pi by 4 minus pi by 4. It is minus root 2 is the answer. And g of 3 pi by 4 is root 2 into sine of 3 pi by 4 minus pi by 4. 2 into 1, root 2 into 1, so it is root 2. This is minimum and this is maximum. Let's look at the curve, how it looks. Okay, I'm giving an input here, sine x minus cos x. It just looks like a normal function. Only thing, you see the maximum and minimum values are not, you can put y equal to 1. So maximum and minimum are crossing, the value 1. And minimum will cross the value minus 1. You see here? Now, instead of 1, I make it square root 2. See here? So the maximum value is square root 2 and the minimum value is square root minus square root 2. So we get this. This is the maximum and this is the minimum. All right. And it is a sine function. It is just that the 0 point changes. The 0 of the curve, the whole sine curve is shifted to the right and minus root 2 and root 2. So this is a periodic function. So the minimum value of g is minus root 2 and the maximum value is plus root 2. So the answer we get of what is the minimum and maximum value of f. So minimum value of is f of minus pi by 4, which is e power minus root 2, and maximum of f okay. So this is the minimum and maximum.